This is the video solution for question number 7. Question number 7 is asking us to draw an area model and find the product for y plus 1 times y squared minus 2y plus 2. If we were to do an area model for this particular problem, since it's a binomial times a trinomial, we're going to end up with 6 multiplications by way of the distributive property. So to keep our work neat, we're going to put one of our polynomials on the top, the other along the side. You can put it on the left side or the right side. We're going to separate our terms, and this is essentially how we get 6 multiplications. And inside these 6 boxes, we will do that multiplication. Starting with the very top left box. My top left box is going to be the result of multiplying y times y squared. Since the coefficients are both 1, we would get 1 times 1, which is 1, keep the common base, and add the powers. That's the product rule for exponents. We're going to do the next box going across the top. Row leader is y, column leader is negative 2y. Again, multiply the coefficients, we get negative 2. Keep the base y, add the exponents. Since they both have a 1, we get y to the second power. Final box on our top row of our area model is going to be a positive 2y. When we have a number multiplied by a variable, we represent that product by making that number our new coefficient for y. 2 times 1 is 2y. Bottom row is really easy to do because we have a 1 as our row header. So anything times 1 is itself, right? 1 times y squared, well, that's y squared. 1 times negative 2y, that's negative 2y. 1 times 2, positive 2. So it's a very easy row to fill out. Next thing we're going to move on to, the beauty of the area model, is that it highlights for us our like terms, and we do have to switch gears. Remember, when you are combining like terms, you are adding the coefficients of the terms that have the same variable raised to the same power, and we are not going to be touching the powers any longer. So let's start by taking our terms that we see are like and circling them. Here's a pair of like terms. And here's another pair of like terms, y to the first power, these both have. So when we write our answer in standard polynomial form, we want to start by choosing the term in the 6 boxes that has the highest degree. And for this problem, that's our y cubed. Next, I'm going to go to the y squareds because they are the next highest power. And I'm going to combine. Remember that we are just adding the coefficients of those like terms. So we have a 1 and a negative 2. Combined, those integers become a negative 1 y squared. Moving on to the next circled terms, we have a positive 2y and a negative 2y. We would call those inverses. Positive 2 and negative 2 add to 0, so we're not going to have a y term at all. Lastly, we have a constant term that needs to join our list of terms for our final answer in standard polynomial form. So we bring down our plus 2, and this is the result of doing question number 7 with an area model, a binomial times a trinomial. There are 6 multiplications, and there were 2 combinations of like terms that needed to occur to get to the final result.